Hello and welcome to another episode of the World War II podcast. I'm Angus Wallace. As the course of the Second World War turned against the Third Reich, some radical proposals and inventive designs were put forward by armaments manufacturers, scientists, technicians, aircrew and even private individuals to the German Air Ministry for consideration as weapons to be utilised by the Luftwaffe. Some proposals were destined to never leave the drawing board, while others not only underwent trials, but were issued to operational units and used in action. In this episode, I'm joined by Robert Forsyth. Robert is an aviation historian who some of you may recall I chatted to in episode 52 when we looked at the Luftwaffe units working with U-boats. Robert has a sumptuous new book available from Osprey Luftwaffe Special Weapons 1942-45. But just before we get started, I thought I'd remind patrons that from my chat with Jonathan Trigg, I made available an extra 30 minutes of John and I talking about the Eastern Front. So if you've not already had a listen, go back and give it a go. It's interesting stuff. If you're not a patron, you can sign up at patreon.com/WW2podcast. The podcast is made possible by those listeners contributing $1 or £1 or so each month, which help me to find the time to put the show together. So that's patreon.com/WW2podcast. Robert, thanks for joining me. So let's start with the Luftwaffe developing special weapons. Why do the Luftwaffe feel they need to develop special weapons? Is it response to something, or do they have I guess Britain does the bouncing bomb because we think, well, we have a special mission in mind. Are the Luftwaffe doing it for those kind of reasons, or?
First of all, special weapons covers a multitude of sins or a multitude of weapons, and each weapon is designed for a specific task. And I think Germany, the answer, Angus, is it's the same as the other belligerents. I think Germany was fighting a multi-front air war, massive fronts with, huge resources committed. And each front had each theatre of war had its own demands. There was demand for anti-shipping weaponry. There was demand for air-to-air weaponry. There was demand for the simple cannon. And so I think, like all the belligerents, there was a weapon needed for each task. And I think in fairness, I don't think there was anything particularly special, quote unquote, in regard to German the desire to develop weapons in Germany, indeed any more than, as you say, the British with the bouncing bomb. But I think possibly the Germans were a little bit more inventive in their approach. That, I think, is born of the fact that Germany has a history as well, and it's true today that they are a race in many ways of engineers. And so there was they had some very qualified engineers, and the society was set up with engineering schools and schools of technology and technical universities, where that they were kind of breeding grounds for sort of engineers, be it tanks or railways or air-to-air weapons. So I think, in fairness, I think Germany just was a nation that reacted to and adapted like any other nation. But what came out of it was probably a greater range of more interesting weaponry. From the sensible to the bizarre, I
couldn't work out if there was sort of trying to make up for deficiencies in their war effort by trying to come up with, because the idea of special weapons is kind of, you hear it towards the end of the war, don't you? Because there's going to be a secret weapon. There's a war-winning weapon. And if that's what they were kind of trying to come up with, that making up for a deficiency, we just can't make enough of this, that, or the other.
Yeah, well, I think there's two dynamics. I mean, firstly, from 1943 onwards, if you say Schweinfurt onwards, the whole, and this is well covered ground, but it is important. The whole of German society was affected by bombing, by deprivation. The transport system was bombed, the factories were bombed. And yet the other dynamic is that when that starts to happen, and it's certainly, from my personal point of view, where the more interesting developments start taking place, is the more they were bombed, the more damage that was inflicted on Germany by the Allied strategic air offensive, the more progressive these ideas became. I think there were also, despite a war being fought, as I said, these technical schools and colleges and universities were still producing engineers, so that from 1942, 43, 41 onwards, let's say, there were still young engineers being qualified. And perhaps against the background of war and against the background of their homes being damaged and just the whole of society being affected, perhaps there was a desire to create something that could be bigger and better and that would finally bring things to an end. Whether that was what the Nazis wanted or otherwise, I don't know. But yes, I think necessity is the mother of invention, and I think the more adverse things became, the record is that the more progressive and inventive things became.
Yeah. Is there a unit within the Luftwaffe that handles sort of special weapons, or is it literally guys in the field going, hey, let's try just strapping this on?
Well, yes, there were, and there were several units. The way it worked, above everything, was a system of experimental centres and test centres. So the German Air Ministry would be the starting point. And if a proposal was put to the German Air Ministry, let's develop a chemical weapon that can be used from the air. Let's develop an air-launched army mortar. Let's develop a steel net that can be dropped from an aeroplane onto a flying fortress. Let's develop this kind of thing. That would invariably find its way to the German Air Ministry, to a department within the technical office, the technical department, or a similar department. If they considered that idea to have merit, then that idea would be put out to the German test centres, whether it was the weapons centre at Tarnowitz up on the Baltic coast, or whether it was the General's Test Centre, Air Force Test Centre at Rechlin, which is in central Germany, or Peenemünde, even up on the Baltic coast. And these test centres would examine it, and then they would test it, and they'd say, no, this hasn't got a cat in hell's chance of working, or this looks quite good, it's promising, let's take it further. And at that point, the Luftwaffe had various what they called commandos, or Erprobungskommandos. And an Erprobungskommando was literally a test command. One of the main testing commands was Erprobungskommando 25, which was the anti-bomber air-to-air weapons evaluation and testing unit. And it was a very small, by comparison, it was a Gruppe, so it had 3 squadrons, one specialising in fighters, one specialising in fighter air-to-air combat, one specialising in ground attack, one specialising in not anti-shipping, but ground attack and other sorts of things. And they would take on the weapons and apply them. Look at them in a more practical sense. Let's see how much damage, they have captured B-17 airframe or something like that. And they'd see, well, how much damage can this inflict? How much damage can such and such a weapon inflict on an airframe? And then they would eventually take it into the air and try to, develop it practically.
They seem to put a lot of effort into trying to concentrate on that Allied bombing offensive, don't they? That seems to be one of their primary.
Well, I think so, because if you look at the Eastern Front, it was primarily a land campaign. It was mass against mass, army against army, with a bit of air support, with some air support on both sides. But at home, this is the thing with the strategic Allied air offensive, by coming at them day and night. They had to do something. It was their industry that was being decimated, and it was their homeland, people's homes. And, the worst thing you can have is your civilian population being killed in the thousands by these bombers, particularly when your own air force is significantly outnumbered. So you have to start creating, you have to start being inventive. And of all the weaponry that was created, and I say particularly from the mid-war onwards, it's not surprising that the bulk of it was put towards trying to make some kind of impact on the massed formations of flying fortresses and liberators that during the day that were bombing Germany, and also at night against RAF Bomber Command, though that itself that was far more complex. At night it was a different, you'll know that the Luftwaffe has developed Schrägermusik, which was the oblique upward firing cannon. And a lot of German pilots couldn't get on with it and couldn't fly with that. It was really a relatively few number of pilots that actually were successful, and they were very successful. And in the book, I quote a couple of counts from pilots and navigators from RAF Bomber Command who just had no idea what had hit them, and it was in the right hands a tremendously successful weapon. But yes, the priority was on shooting down bombers at any cost, certainly from 1943 onwards, surely because if they didn't stop the bombers, the factories would be bombed, which means they couldn't manufacture. You couldn't get a train from A to B, and apart from anything else, your family was at risk from bombing. So yeah, that was where a lot of pressure was to come up with weapons.
They seem to go down the route of putting heavier and heavier cannons into planes. Why are they thinking of putting cannons in and not potentially building more planes or increasing rate of fire? Or
okay, so with the bomber war, the anti-bomber war, you had to bring a flying fortress down. That's a big piece of metal in the sky, bristling with 50 caliber machine guns. A stream of anything below 20 millimeter is going to do nothing. The Germans developed something called the Minengeschoss shell. I mean, basically, as you had armored piercing shells and you had incendiary shells. What the mine shell did was basically create the maximum amount of energy to penetrate the metal of a bomber, and then to explode and call into fire and cause the maximum amount of fire. But it had to be a heavy round. It had to have the force. And the only way they can do that was develop to do that, you had to have a heavy weapon to fire a heavy round to cause that damage. That then had the problem of range. You had to get in close. And there was this continual battle between creating a heavy caliber weapon that could inflict significant damage on a big aircraft like a Liberator or a Flying Fortress or even a Lancaster during the daylight raids towards the end of the war, on an aircraft that was a fighter that was small and had to have maneuverability. And that was the problem. So then you say, well, then we'll just have a bigger aircraft. We'll stick a big 50 millimeter cannon on a Ju-88 or an Me-410. These are twin-engined. Ju-88 was effectively built as a fast bomber. The Me-410 was basically born of the Me-110, which was the German twin-engine Zerstörer concept. So again, it was but a twin-engine aircraft. These things lack maneuverability, so they were prey for the Mustang fighters and the Thunderbolts. So it was that sort of dichotomy between maintaining maneuverability and speed, and to get through a bomber formation quickly, because you didn't want to hang around, because as a German pilot you had all these 50 caliber machine guns pointing at you, but you had to make your round count. And to make a round count against a B-17, it had to be big, because you had to expend as little ammunition as possible. And that's another problem, because you only had a very slow rate of fire so, with the bigger machines. But things got better. The Germans developed one cannon. It was built by the Deutsche Waffen Munitionsfabrik, the MK108, which was a 30 millimeter cannon, and that they mastered. That was a really good weapon, because they mastered the art of making a gun out of cheap pressed metal stampings, and that was lighter. They called it the pneumatic hammer because it had a very slow rate of fire, and it was very, like that. But they got lightness with heavy caliber. And indeed, they put that weapon into Focke Wulf 190s and ME262s. 4 such weapons would be built into the nose of an ME262. But that's another issue, because sometimes you can have an aircraft that's too fast. So that became a problem in itself, because pilots who flew the ME262 with the MK108, you've got a very, very high speed interceptor closing in on B-17s at, the rate of hundreds of kilometers an hour, and you've got a slow firing 30-millimeter cannon. Difficult, but they mastered that with that weapon. Yeah.
If you're putting cannon on existing airframes, how much of a problem is that? Because these airframes wouldn't be built. When they plan the airframes, presumably they weren't built for the tolerances of taking a large cannon. So are they having to engineer planes or come up with recoil? Recoil must be an enormous problem on these large caliber cannons for I mean, aircraft are relatively actually light framed machines.
Indeed. I mean the two fighters were the Messerschmitt 109 and the Focke Wulf 190, and both aircraft underwent significant upgrades and almost bordering on redesign. Well, they were redesigned actually. The 109 had a longer service period. Obviously, it went back to the Poland and onwards, whereas the 190 was introduced in 41, 42. But in the later units that employed the 190 from 44 onwards, the later marks of 190, the A8s or the A6s, A7s, A8s, they had bits of armour panelling put on. The airframe had to be strengthened to take these weapons. Underwing pods were fitted. And yes, a heck of a kick. And as I said, that also introduced weight. And weight affects maneuverability, but you want a stable gun platform. And certainly with the radial engine 190, they flew in. There were units that were called Sturmgruppen. These were specialist assault units, squadrons designed to attack bombers, and they would go in really close. And these would have pieces of armoured plating put around their cowlings, under the cockpit, and loaded with these MK108 cannon and 20mm MG151s, which was a longer barreled weapon. Recoil was massive, but the airframe held, and that's testament to Focke Wulf, I guess.
It's basically just sort of every few flights they're shaking themselves to bits, and someone's got to have to check all the rivets on these things.
Yes. And then later, later came rocket armament, and that was because what they really wanted to do was to develop standoff, fire and forget. I think that was the way they were going. Because aside from the problem of escort and the P-51 for fighters, the Americans came in more and more mass, and so the further they could be out of range, the better. So the first step in that direction was to adapt an army mortar, the 21 centimeter Wurfgranate, where they put this big tube under the wings of the aircraft, one under each wing in the terms of on a single engine fighter, and 2 such tubes under the wings of a twin-engined heavy destroyer aircraft. And this thing was a big spin stabilized mortar, as I said, converted from an army weapon. And there was a logic to it, because the logic was not to try and necessarily destroy a bomber with a hit, although that did more by luck happen, but mainly to scatter and disperse a bomber formation, because a formation of several hundred B-17s has many, many hundreds of machine guns. So if you can scatter the formation and disperse it and disrupt it, you're then increasing vulnerability, and then you get stragglers, and fighters can go into it to go for individual bombers. So the plan was initially to disperse and scatter a formation. Then that sort of worked, but it didn't really. It wasn't particularly effective. So then technology kicks in, and there were some amazing designs. There was a company called Ruhrstahl who made the X4 rocket, which was a wire-guided high-speed rocket, and it was tested. It wasn't used operationally. I think it was too little too late. The end of the war came. But one weapon that was used was the 55 millimeter R4M rocket, which was used under the wings of ME-262s. And they were put onto wooden racks, 12 under each wing of an ME-262. And these things were they did a lot of damage. They were more accurate. They were very high speed. A few years ago, I corresponded with a pilot of a B-24 Marauder. And the thing with the Allies is their intelligence, not only did they have very little information about these weapons, but they actually doubted their own aircrews. When they experienced these things, often the Allied intelligence debriefing officers sort of said, well, are you sure you saw that? Or, well, nah, that's not right, son, go and get some rest. That didn't happen. And I remember corresponding with these quite a few B-24 Marauder crews. And one guy told me that a 55 millimeter rocket went straight through his Marauder from the nose gun position. It took his leg off and half of his arm and went through longitudinally, went through the Marauder and came out just diagonal of the tail assembly. And believe it or not, he flew that Marauder home. But my point is, these things were horrendous and they did a lot of damage. And the other thing they developed was a range of weapons called the Sondergeräte, which basically meant special weapons, special devices. And these things had photoelectric cell technology, which was amazing. So, I mean, they would fly under again, it was like Schrager music. But in a daylight version of it, they would fly under a B-17 or a B-24, and the photoelectric cell technology would tell the weapon when to fire. So fire and forget, and very accurate. Very accurate.
That's the magic eye technology.
Magic eye technology, yeah.
So that takes presumably takes the stress off the pilot having to worry about having to pull the trigger at the right time.
Absolutely, it's light and shadow, and the pilot's job was to make the correct approach from the correct direction, get roughly into firing position, and bang, off it goes, and the weapon does the rest. And one of the main companies behind that was Rheinmetall Borsig. I was very fortunate in writing the book because I started work on the book about 30 years ago, and I was able to find back then through some very helpful guys in the Imperial War Museum in London. In Britain, we had an establishment called Fort Halstead in Kent, and that was a government weapons evaluation centre, and they interviewed many technicians and ballistics engineers with companies like Rheinmetall Borsig and conducted interrogations in immediate post-war period. And these guys wrote up a lot of their reports very much from a technical perspective. But what I tried to do in the book was to try and bring together both the pilot's perspective and also something which is not covered, which is the engineer's perspective. Why do we need to build this thing, and how are we going to build it? How are we going to design it? And I found that very fascinating. And I hope one of the strengths of the book is that it's interesting. Of course, it's interesting reading about the man in the cockpit, but actually, how did this weapon come about? Who were the guys that actually built and designed this thing? And these reports were a complete revelation, and they form the backbone of the book.
What is the process or what was the process for coming up with these? I mean, does a pilot suddenly think one day, well, do you realise if we could put a really big thing in and we could do this, or is it, Goering going, hey, I've seen this gun, we need that in, and everyone going, but it won't fit. I don't care, just make it happen. Or, what is it? Who's driving this forward? These programs?
Well, it's very interesting, and yeah. So basically, pilots themselves, you're absolutely right. Some pilots. There was a man called Kornatsky who formed something called the Sturmstaffel, which was to fly these very heavily armoured 190s against B-17s. So that and to get really, really close. So from a tactical development point of view, that came from within the Luftwaffe. But then you'd get civilians. And I found one example, I mean, going from one extreme to another, one example of a suggestion from a civilian to create, and this is absolutely true because I got the report and it's in the book, there's in a sketch of it, artificially created torrents or gusts of air to, as I said earlier, to destabilize bomber formations. But it wasn't dismissed. It got as far as the German Air Ministry, and they considered this. And then there were the specialist Luftwaffe units, as I said, units like Erprobungskommando 25, which tested steel cables, air-to-air bombing, steel nets, chemicals designed to spray over the windscreens of Allied aircraft to drop into foul engines, and so on.
They almost say like Man from U.N.C.L.E. or James Bond, aren't they? Those kind of developments.
Yeah, and they took it in a very, perhaps I shouldn't say this, but in the typically very clinical German way of assessing things. It wasn't. It wasn't about having a laugh. I mean, this was serious. I mean, they really looked at it and you can see. I had access to the weekly reports of Erprobungskommando 25. They never turned anything away. They looked at everything, and if they felt it could work, they develop it, and sometimes over a period, it could take 2 years, and eventually they say, no, this isn't going to work. But it was thorough, and they persisted with it. And I guess that was a reflection of the threat that they faced, that their homes were being destroyed and their factories were being burned, certainly from the daylight anti-bomber perspective. But they never turned any suggestions down.
That'll be why they, in the closing months of the war, they do actually consider ramming techniques, which I couldn't help but think ramming is another phrase for suicide pilots.
Yeah, it is, Angus. I mean, yeah, whichever way you look at it, that's the end result. I mean, there was an episode. I think it was the 7th of April, 1945. A unit was formed called the Schulungslehrgang Elbe, which was the Elbe school cadre, to give it a sort of polite name, cover name, and they called for volunteers to bring down a bomber, if they'd expended their ammunition, to bring down a bomber if necessary by ramming. And they were young pilots. Well, not all. Some of them were. A few of them were instructor pilots, but the majority were young pilots imbued with National Socialist fervour, and the bulk of the Luftwaffe command staff, people like Adolf Galland and people like that, were very against it, and they didn't really want to have anything to do with it. It was a fringe. It was a thing that developed on the fringes. So yeah,
it sounds nuts when usually it's lack of pilots is usually the problem. But I guess from the Luftwaffe's point of view, if you manage to get a plane in the air, it was lack of fuel that's the problem rather than the pilots and the planes themselves.
Yeah, I mean there was a sort of intermediary of that with the Mistel composite bomber, where they put a fighter, a 109 or a 190 fighter, and mounted it on top of a war-weary Ju-88 airframe, which in a way made sense because by that stage the Luftwaffe bomber force was, we're talking from the summer of 1944, and the Luftwaffe bomber force was largely redundant. So Junkers had the technicians, again at Junkers, civilian technicians at Junkers, came up with the idea of mounting a single-engine 109 or 190 on top of a Ju-88 airframe to remove the forward cockpit element and to put a massive hollow charge warhead on the front and to send this thing off to enemy fortifications, or, as it turned out, to bridges over the Oder against the Russians coming from the east in March to April and into May 45. And they were used with, sort of spotty spotty success. Bridges were hit, and in fact, they even damaged a bridge over the River Rhine.
So the 109's piggybacking. So is that 109's piloting the Ju-88, and he points it in the right direction? Does he, at the right point, he flies off, and then does he remote control fly the Ju-88 to hit the bridge and pilot his plane at the same time?
Not quite. No, this is where the fire and the beginning of fire and forget. These things would take off. They would fly to the target. The upper pilot would have control. He would be flying the whole thing and controlling and linked. So his control services were mirrored. The control services of the Ju-88, the ailerons, the flaps, everything else were mirrored, and they would then fly towards the target. And from March 1945 onwards, these would be bridges over the River Oder, because they were trying to stop the Russians crossing the Oder. And they would get to within a few hundred yards of a target, enter into a shallow dive with Russian anti-aircraft fire pinging away at them from the banks of the Oder, and they would release it and then detach. And no, there was no control there afterwards. It was literally fire there. So the upper component would then become a fighter and fly its way home. And I must just tell you one other thing. There was an operation plan called Drachenhöhle, which was Dragon's Lair, which was Goering's. You asked whether Goering had a hand in it, in things. Not really. The one thing he did have a hand in was a plan to bomb Scapa Flow with Mistral composite bombers. And it was highly secret, and all the pilots, the few pilots that were slated to fly it, were promised a Knight's Cross if they came back. So they were to fly these things across the North Sea and try and take out. I think in Scapa Flow at the time, I think there was the Illustrious, and they conducted air reconnaissance, and they found the Illustrious and the Indomitable and some other British heavy warships in Scapa Flow. And had they done it, I mean, they were practicing with wooden. They had wooden models, and they were airfields in Denmark. And had they actually done that, they could have caused some damage. But there was a betrayal from within, and they basically London found out about it, and they sent a squadron of mosquitoes over to Denmark, which shot up the airfield and damaged the Mistral. So,
it would have been a huge propaganda coup for the Germans.
Yes, and I might add, Angus, that the Focke Wulf 190 that hangs from the ceiling of the Imperial War Museum in London is an aircraft that was slated to fly that mission.
Is it really?
Yeah, it is. And if you look at it, you can see under the underside of the 190, you can see the attachment points for the rigging that would have attached it to the Ju-88.
Yeah. Fascinating. I didn't know where they'd found. Yeah, that's interesting. So, but by the end of you've alluded to the ME-262 coming online. I can't help but think when you're reading through the special weapons, actually they're all really designed for the 262, but it's almost as if the weapon design and the plane design never quite marry up to fit them on. Or have I got that? I'm misreading that. It looked like the ultimate special weapons carrier.
Yeah, yes. I think the 262 was where probably the two met. And to use the example again, it is the 55mm R4M rocket, which was a very fast rocket loaded beneath the wings of a very, very fast interceptor. And I think that probably, because they had to get past the Mustangs and they had to get through a bomber formation quickly. And I think that was probably the nearest they got to accuracy and speed combination with a purpose-built interceptor and a purpose-built weapon to shoot down bombers. And I think that was probably the apex. After that, they were still inventing. These young engineers and designers were still inventing weapons. They were still just about pilots to fly them. But the aircraft production just couldn't keep up. And that also engine production couldn't keep up. So it was really the numbers of aircraft that was the problem, and the lack of training as well. And I think that stymied, that's really what, and the growing weight of the Allied air offensive. It was just the end, really.
It just becomes too much. So ultimately, did any of these weapons cause the Allies any serious concerns?
That's an interesting question. I think they were shocked. I think rockets shocked, by which I mean underwing rockets. Rockets shocked them. They did do some damage, but I think they just weren't enough. Had they had squadrons of and I mean squadrons, they only had one wing of 262s in the north around Berlin, JG7, and they had a small unit of 262s in the south, JV44. There were some bomber units that were converting. They just didn't have enough 262s, and they had even fewer R4Ms. And the 190s that were the heavily armoured 190s that were still flying, they were just, more and more Mustangs, Thunderbolts, Lightnings, Spitfires. They were just getting nailed. And they just couldn't train fast enough. Losses were increasing. They couldn't produce enough aircraft. There were always delays with engines. And the factories were being bombed. It was just a perfect storm, really. And it was a cycle. They couldn't beat it.
It's interesting you think that the Allies were surprised by the rockets, because the Allies are putting rockets on planes at this time, or are they just using them for ground attack?
They were used for ground attack, but I think what it is, and we'll come on to ground attack in a minute. I think what it is certainly if you're a bomber crew, the psychological impact. You see fighters coming at you from the front or from the side and they're way out, and cannons open up, machine. But these things must have been ferocious to witness, and really psychologically, they had an impact. And if your buddy's B-17 goes, hit, bang, it's one thing seeing your buddy's B-17 hole with cannon holes and just about getting back on 3 engines or whatever. But to see there's flak as well, I admit. But to see a neighbouring aircraft just lose a wing or just blow up as a result of some rocket. I mean, the psychological impact of that, and certainly when you read the post-mission intelligence reports, you read between the lines, and when they finally started to believe their air crews, you could see that made a psychological impact, if nothing else.
You mentioned ground attack. Presumably, all this kit, heavy weapons, could be repurposed for ground support, which must be something they've not been able to do very well. Since they withdrew the Stuka and dive bombing fell out of fashion at the start of the war when you're putting heavy ordnance on. Is it effective?
Yeah, absolutely. I mean, absolutely. I mean, what they did was they developed the photoelectric cell technology. To put it crudely, instead of firing upwards, they would fire downwards, and they were using magnetic technology to pick up iron mass and things like this to hit T-34s. That didn't really go anywhere. Again, too little, too late. Rockets were used. They had the Panzerblitz and Panzerschreck rockets, similar concept to batteries of R4M missiles under the wings. Again, they put them on FW-190Fs in the ground attack role. They were used around Berlin in the final weeks of the war. Again, Angus, it was just too little, too late. There were proficient pilots, but you're talking a handful of pilots, whereas you're talking hundreds of T-34s and Joseph Stalin tank destroyers and what have you. And it's just this overwhelming tide. I think that's the thing. There was no doubt the Germans could devise the technology. There was no doubt these engineers at Rheinmetall Borsig and Mauser and DWM and all these other German factories, they were still producing high-end weaponry. But the factories were being bombed, and so they couldn't get enough weaponry and enough carrier aircraft out there to make an impact, whether it was against B-17s or T-34s. And by that stage, the anti-shipping war had finished. There was the Germans did develop some remarkable anti-shipping weaponry. The HS-293 and the Fritz X were remote-controlled, different types of bomb, but remote-controlled bombs. They had some success with these in the Mediterranean.
Is that radio-controlled?
It's radio-controlled. It was Telefunken developed the Funkgerät 203, I think it is, which was a radio-controlled system, really sophisticated, so that they could fire these things at Allied ships from, again, far out, and they were guided by radio control with using a joystick in the cockpit. Yeah, in 1944, off Anzio and in the Mediterranean, they were effective. They sank ships. Not many, but when they were used, they sank ships. The problem was some of them were used on Heinkel 177s, so you had a bad aircraft to start with to carry the things. It wasn't and some were carried on Dornier 217s, which were much more effective aircraft, much better carrier, less vulnerable. But yeah, I mean, anti-shipping weaponry was very, very sophisticated. And torpedoes. The Germans did put a lot of design effort into aerial torpedoes, and they had several squadrons that operated with weapons and were very successful with them.
It makes you wonder if at the end of the war, if the Allies managed how much of these, if there's a rush to get the papers and how much of it has found itself into modern weapons, and this is the start of guidance systems, and how much of that has followed through, and was there a rush like the Germans and Americans competing to get the technical notes from these factories to rip off?
I think I think that did happen. I think the emphasis was on aircraft design and jet engine technology, probably as a priority. But following that closely was the weapons guys. And as I say, in writing the book, it's evident. It's there. The British at Fort Halstead spent a lot of time talking to these former weapons designers from Rheinmetall or Zig, and the war was over, so they were cooperative. Some of the reports were reports written by German technicians and then translated, and some of them were the transcripts of interrogations. And the detail and the length of the reports is testimony to just how much the Allies wanted to know and how they felt it was important. I'm sure to some extent it must have provided inspiration, incentive, set them on their own way to developing their own weapons, because these guys were, they were very clever. As I said at the beginning of this discussion, the Germans are a race of engineers and technicians and designers. One thing that didn't shut down, unlike the factories, was the ability to keep designing, the ability and the fact that young engineers were being qualified throughout the war, and they were young men, a lot of them. So, but I think the priority was aircraft development and engine technology.
It's fascinating because it got me thinking by the end of it, thinking, God, I wonder if you can draw a line sort of to the A10 tank buster. It's not it doesn't look that much different from a 262 with a bloody great cannon on the front. When you think about the Gulf War, the whole thing was sold on precision bombing. Well, that's kind of fly-by-wire. This is sort of the start of this precision of what you're trying to do, rather than maybe just rate of fire or mass producing huge amounts of things. Let's try and be quite specific on what we're trying to achieve.
I think you see that, actually. It's a good point. I think you see that in German, on the air-to-air weaponry. I think you see that in German development because, as I said, the initial phase was, phase one was let's shoot down a bomber using cannon or gun. Phase two was, oh my goodness, they're coming in too greater numbers, we can't deal with this. So what we've got to do is break down the bombers, break the formation, make them vulnerable, break up the formations. And when that didn't work, phase three was we've got to develop weaponry that every rocket will cause some damage, and we've got to therefore make them much more accurate. So the rockets become accurate. With the anti-shipping war, as I said, they developed the control technology, but it was there, but the Germans basically were retreating, so they were going inland. So the shipping war came to an end, and it was redundant. It was redundant technology, but it went from let's shoot something down, let's scatter things, to we need accuracy. And I think that followed on after the war.
Well, that would seem like a good place to finish. Thank you, Robert. Loyal listener, I've been chatting to Robert Forsyth. If you want to find a copy of his book, it is Luftwaffe Special Weapons, 1942-45. I will, as ever, put a link on the website. I'm not sure what we're talking about in the next episode, so it'll be a surprise to all of us. As ever, I'm Angus Wallace, and thanks for listening.